This video is going to be a tutorial on how to find the coefficients of a Fourier series with an example of a square wave. Here you see the formulas that we have to use to find the coefficients of the Fourier series and sum them up. Okay, and below that we have the example, which is just going to be a square wave with an amplitude of 1. Now, to save time, I have already entered these formulas into Matlab. Since the integral is going to be using t as its variable and the series uses n as its variable, then I stated them as variables using the symbolic toolbox here. Next, I entered in the constants, which is going to be the period of 4 for this example, which means that from here to here is 4, because that is when the square wave begins to repeat itself. I just chose 4 arbitrarily. This is just an example. Next we have omega naught. This is the frequency, and you can simply type in the formula to find the frequency, which is 2 pi divided by the period. And I'm going to leave blank for until the end, because n is the terms of the series, and we're going to enter that as a vector. Next we have a naught, an, and bn. This integral function works by entering first the function itself, the variable, and then the limits of integration. Now I will show you why it is entered this way. In this example, the function is just 1 from 0, and since the period is 4, this is going to be 2, so the function is 1 from 0 to 2. And then there is no point of integrating from 2 to 4, because that is just 0 and it is pointless. So that is why we have 1 for the function, t is the variable, and the limits are 0 to 2. This is the same for an and bn. Very simple, just multiplying the function times cosine and the function times sine of n times omega naught times t, as you can see again here. Okay, so now let's say we wanted to find the first 7 terms of the Fourier series. So we enter n as a vector from 1 to 7 and run the program. Cool. So n is displaying which terms we are summing up. Here we have a naught, which is actually the average of the function. 1/2 actually makes sense since the amplitude is 1, so the average would obviously be 1/2. So that's correct. And then am is just a vector of 7 zeros, and bn is 2 over pi, 0, 2 over 3 pi, 0, 2 over 5 pi, etc. So if we were to sum all of these up, we would have the coefficients from 1 to 7. Finally, if we go back to the actual formula, we see that 1 actually goes from 1 to infinity. If we were to actually sum up all the coefficients from 1 to infinity, then we would get exactly this square wave. Thus we can assume that the more n's we sum up, the more accurately the square wave is going to be represented. Thank you for watching the video, and I hope you learned what you came to learn.